So here is some definitions that you need to know for the exam. You need to know what a conductor is and give me an example of a conductor. Know what an insulator does and then give me an example of a insulator. Okay, then know what a superconductor is and then what would be an application of a semiconductor. And then you had the superconductor and be able to tell me what is a superconductor, when does it work, and then what would be an application of superconductors. And then you notice that you have some videos on YouTube that they're only about 5 minutes long, and they will introduce you to the concepts of the semiconductor and then the superconductor. Okay, all I want you to know is that some substances like to give away their electrons and other substances like to take electrons. So when you rub them together, one is going to have electrons on it and one is going to have the absence of electrons on it. So that means that this one is going to be negatively charged and then this one is going to be positively charged. So you can physically separate electrical charges by rubbing them together. You can also separate electrical charges chemically, and that's how a battery works. So you don't need to know which kinds of substances like to give up their electrons and which kind likes to take their electrons, but I could give you that chart on the exam and you have to be able to read the chart. Okay, and this would not be on the exam. That's a more exhaustive list of different kinds of substances. All right, you need to know how a Van de Graaff generator works. So again, it's going to be a physical rubbing of materials that separates electrical charges, and then one type of charge goes to the dome, and then one kind of charge goes to the wand, and then if there is too much charge on the two, then there will be a miniature lightning bolt that will connect them. So it's like having a wire from the wand to the bulb over there. And so air is actually a pretty good insulator. It does not allow electricity to flow through it, but if there's too much electricity, air can break down and then you have a lightning bolt. Okay, can you explain how to pick up a piece of paper with a charged rod, and can you explain how to pick up a piece of aluminum foil with a charged rod? Okay, so go back to the videos where I talk about this, and then also watch this little video on how to do it. Okay, then the gold leaf electroscope. Can you explain why, when you take the rod and you bring it close to the gold leaf electroscope, why do the leaves open up? If I gave you a picture of the gold leaf electroscope like this, and then I give you a rod, if I was to say that this rod had negative charges on it, could you tell me what charge would be here and then what charge would be down here? Okay, so that would be something that you should be able to do on the exam. Okay, and then we also talked about electromagnetic shielding. And so this is going to be, if you have a piece of metal, it only works with metal. So if you have a piece of metal and you put it in an external electric field, now remember, electric fields carry electricity, so that a lightning bolt, so when you got a cloud up here and then the ground is down here, it sets up a tremendous electric field in between. And then the air can break down, and so the lightning bolt is going to follow that electric field line. So the question is, why, if you put a piece of metal into that electric field, which is the blue arrows in that, why is there no net electric field inside the piece of metal? And so I encourage you to watch that thing about the Faraday cage and find out how it does that. All right, so that finishes up this lesson on electrostatics. And so in our next review, we're going to start in on circuits.